All right. Hello, everybody. I'm Dr. Gray. I'm here to talk to you about experiment number 5, a simple acid-base titration. Now, this is a very commonly used technique. The purpose of this technique is to use one substance that you know quite a bit about to determine some information about this other substance. Now, what we're going to be doing in lab is we are going to be doing an acid-base titration. So that means that we're going to be using an acid and a base, as one would imagine. Now, what that means is that we will use the known concentration of one solution to determine the concentration of the other solution. Now, if you will look at page number, let's see, well, on page 71, the first page of the experiment, you're told a little bit about a titration, what it consists of, what are some of the variables. Now, simply mixing an acid and a base together doesn't tell you much about either of those. And the only way that you're going to learn something is by using something known as an indicator solution. Now, for this lab, we're going to use an indicator solution known as Phenyl Thaline. Now, this is a solution that has a color change at a neutral pH. And in Chem 1, you don't really get into pH. However, what we want you to take away from this is going to be the point where we have concluded our titration, where you have an equal part of acid and base. The base is fully neutralized by the acid, or vice versa. So what you need to know about this is basically that's what we're going to be using in order to determine when we are actually done with our reaction. So the information that you're going to be told about the two different solutions, if you look on page number 76, that's where we talk about the solutions. Step 5 on page 76 says, carefully fill the Buret. Okay, before I get into what a Buret is, it says with 0.75 molar NaOH. Okay, so that's the base solution. So what that means is you're going to use a base to determine something about, well, the molarity of an acid. Now, the base that we're going to be using is sodium hydroxide. The acid is HCl. So we're going to mix these two different solutions with one another to, well, determine how much acid is present in our solution. So this 0.75 molar sodium hydroxide solution and this HCl solution, from a balanced chemical reaction perspective, will look like this. NaOH, or strong base, I'm going to put the subscript AQ, meaning it's aqueous, it's a solution, plus HCl, also an aqueous solution, is going to yield NaCl, which happens to be aqueous, and H2O, which is a liquid. So this is our overall reaction. This is a balanced chemical reaction. What this balanced chemical reaction tells us, and that is very important for us to appreciate, is the ratio of reactants to one another and products. This is a 1-to-1-to-1-to-1 reaction. The important part about this is the takeaway right here. 1 mole of sodium hydroxide perfectly reacts with 1 mole of HCl. So what that means is 15 moles of NaOH reacts perfectly with, you guessed it, 15 moles of HCl. Now, what we are going to do is we are going to use a piece of glassware known as a Buret. Now, a Buret looks like a very tall straw. In a Buret, I'm going to go ahead and do a nice little drawing of a Buret right here. It looks like this. It has a pointed tip to it, and then it's got this little valve right here that you can open and close with this kind of adjustable lever. So right now I've drawn it. So let's see, here we go. 0 milliliters, 50 milliliters. Now, whenever you get your Buret, like I said a moment ago, you're going to use 0.75 molar solution of sodium hydroxide. You're going to put that into the solution, and what you'll do is you'll fill this basically all the way right up to that 50 milliliter line. Now, one important thing to remember about a Buret is I drew this line right here, 0 milliliters. Let me go back to the blue that I was using a moment ago. 0 milliliters. Okay. What you'll notice about a Buret is there's this valve right here, and then there's this void basically. So below that 0 milliliter marker and where that valve is, there is a volume. So there is some solution that stays in there, or some solution volume that you, well, need to account for. Essentially what this means is that a Buret is very, very effective for measuring a solution within the range from here to here. So what I mean by that is if you fill a Buret all the way to the top, to the brim of the instrument or the piece of glassware, then open it up and let the solution flow out. So if you filled it up to here and let it completely empty out, that is more than 50 milliliters because of the fact that, well, you need to account for this volume right here, and you need to account for this volume right here. My point is, do not do that. This piece of glassware is a lot like a volumetric flask. It's very good for measuring 50 milliliters and measuring within the confines of this point and this point right here. If you go above that, you're not going to get an accurate measurement. If you go below that, you're also not going to get an accurate measurement because you do not have any sort of lines indicating the volume that's above nor the volume that's below that 0 milliliters. So a very cautionary tale, make sure that you do not overfill it and do not let the solution run out completely. Okay, so that's basically what a Buret looks like. Now, the way that you're going to do a titration would amount to something like this. You will have an Erlenmeyer flask. And in that Erlenmeyer flask, you're going to put an HCl solution. And I believe that your procedure calls for 25 milliliters of that HCl solution. You want to be very careful to get exactly 25 milliliters of HCl. To that, you're going to add 3 drops, 3 to 5, I'll say, drops of our indicator solution, phenyl thaline. So this is one of those cool words that if you're a chemist or a biochemist for that matter, you get to throw a bunch of consonants next to one another, like pH, th. Who would think that that could be used in a word? But there you go. As a chemist or a biochemist, you get to say things like that and know what they do. So when you add this phenyl thaline to this solution, it's going to be clear. Phenyl thaline will not do anything in an acidic environment. Okay. Then what you're going to do is you're going to have your Buret, my novelty size straw here, with my valve right here. And I'm going to fill this up to exactly 50 milliliters. And I'm definitely going to know where my 0 milliliters is. And what I'm going to do is I know that my solution, so what I have is 0.75 molar NaOH. What I'm going to do is open this valve, and I'm going to put a piece of paper or some sort of contrasting surface, like a white surface, behind or below my Erlenmeyer flask. Because what I want to do is I want to add sodium hydroxide until I see a color change. And that color change is going to be a very, very faint pinkish violet type of color. So I'll say pinkish. As soon as my color change occurs and persists, I'm done. My titration has completed. And what I want to do is I want to track the volume of sodium hydroxide that I had to add. So I'll say I started with 50 milliliters, and then I go all the way down here. And let's say that at this point in time, I'm done with my titration. Okay. So what I will do is I'll say, well, 50 milliliters minus, and let's say that this is about 34.5 milliliters. 50 minus 34.5 milliliters is 15.5 milliliters of sodium hydroxide. So when I have a volume and when I have a concentration, then I can figure out the number of moles. And we know that our reaction is a 1 mole of sodium hydroxide to 1 mole HCl. So what I want to do is I want to take my volume, 15.5 milliliters, and I'll say 0.0155 liters. Keep in mind, this is just an example volume that I'm doing just for the sake of the calculation. I'm going to multiply this by my concentration, 0.75 molar. Okay, so when I have liters and molarity, which is moles per liter, I will get, let me use my calculator, 0.0155 times 0.75, and I get 0.011625 moles of NaOH. So that's the exact number of moles of sodium hydroxide that I had to add to neutralize the HCl. So if that's the amount of sodium hydroxide I had to add, do I know how much HCl I had to add? I do. I do because of the fact that this is a 1-to-1 molar ratio. So I'm going to go ahead and write this as 0.011625 moles NaOH reacts perfectly with the exact same number of moles of HCl. Now, what I'm asking you for and what you need to do for this is you need to figure out the concentration of HCl. You might see that written like this, HCl, and then put a bracket around that. What's the molar concentration of this? Well, the molar concentration is just going to be the number of moles, 0.011625 moles, divided by my volume. I had exactly 25 milliliters of HCl. So I'll write my volume 0.025 liters. I'm writing my volume in liters, so I took 25 milliliters and I converted that to liters like this, 25 mils, 1,000 mils in 1 liter, and that's where I got the 0.025. I did the exact same thing with this value right up here. I just kind of streamlined it and sped it up. Okay, so 0.011625 divided by 0.025, and I get a concentration of 0.465 molar. Now, if I go back through my calculation, I can see that my lowest number of significant figures is 2, so I want to reflect that. So I'm going to say that this is 0.47 molar, or if I want to write scientific notation, 4.7 times 10 to the negative first molar. So that's how you do this calculation. That's all that there is to this titration. I just added a little bit of the sodium hydroxide, 15.5 milliliters. In this hypothetical example, I used my volume of sodium hydroxide with the known concentration of sodium hydroxide to calculate the concentration of my unknown HCl solution. And that's all there is to it. You do this a total of 3 times. The great thing is that if you've done it once, you basically can do it 2 times and have a pretty good idea of the volume that you need to add. So you don't need to be adding the solution at a very, very slow rate. One of the biggest things that people mess up on with this and titrations in general is they forget to add their indicator solution. If you don't add an indicator solution, your solution's never going to change color. And so it's going to take forever. It's going to take forever because it's simply not going to react. It's not going to, you're not going to be able to visualize anything. All right, well, I hope this is helpful. Have a good one.